Today I want to demonstrate using the OCI Bastion service. It's a fairly new and very nice Generation 2 facility. Before diving into the Bastion service, let's set the context by taking a quick look at a typical OCI-hosted website. This is the sort of thing we would configure for a small to medium environment. Here we've got a database running in a DB system, and then we've got two web application servers. The website will be accessed by end users using browsers through a load balancer, which we'll probably protect with a web application firewall. Development and administration staff who need to use SSH to get to the operating system or SQLnet to get to the database, they're going to connect through some sort of Bastion host, which is hardened against attack. When designing cloud services, best practice is always to place the database and application servers on private subnets. That means that they are not exposed to the internet. They can, of course, make outbound calls to external services through a NAT gateway, but nothing can contact them directly. To connect to them, you have to go through a Bastion host. This would typically be a VPN server or jump server. We usually configure both. But there is now, within OCI, an alternative technique, using the Bastion service. The Bastion service is really a transparent SSH proxy. However, in addition to permitting secure and ephemeral SSH terminal sessions to Linux virtual machines on private subnets, it can also establish SSH tunnels. That means you can use client-side tools like SQL Plus or SQL Developer to log on to DB systems or to autonomous databases. Or if you have Windows compute instances, you can run the remote desktop to connect to them as well. But whatever you're using, the security is unbreakable. It's enforced by OCI's Identity and Access Management. So to use the Bastion service, users must be known to OCI, and OCI will take care of all the authentication and authorization. So, let's do it. First of all, there are a couple of requirements for the virtual machines. They need to be running the Oracle Cloud Agent, and the Bastion service must be enabled. For example, if I go to Compute and Instances, and in my compartment, I've got these two compute instances running, Web 1 and Web 2. Choose one of them, and Oracle Cloud Agent. That needs to be running, which it is, and within the Oracle Cloud Agent, the Bastion service must be enabled. For machines created from Oracle supplied images, and of course your DB system nodes, this should be done already. If not, it's just a yum install. Now we can create the Bastion. We'll place it on the public subnet. That's the whole idea. It's meant to be internet facing. Then we'll specify the accepted incoming CIDRs. And of course, you have to make sure there are appropriate route tables and security lists in place. The Bastion lives in identity and security. Down the bottom, Bastion. And create Bastion. I'll put it on my workshop VCN and select the public subnet. The CIDR I'm going to give it, you can be as strict as you like on this. For simplicity, I'm going to let anyone on the internet connect to it. That means I'm relying purely on the IAM security to control who's allowed in. In advanced options, see here you can specify how long the ephemeral sessions are allowed to live, and the maximum default of 3 hours. That's good enough for me. So create the Bastion. My apologies there, I didn't save the cider correctly. That's got that in there now. Create the Bastion. We see that it's creating, and that will take just a few seconds. And now that it's created, we go on to create a session. So creating the Bastion itself is a once-only exercise, and you need Holly privileges to do that. But your users, the developers, the junior administrators, they will then create their own sessions subsequently. Sessions can be of two types. We have managed SSH and SSH port forwarding. Managed SSH, that's terminal connections. Port forwarding is the tunneled connections one would use for SQLnet or RDP. I'll use managed SSH for now. We then need to give it the username, which we're going to use to log on to the compute instance. The standard OCI username, OPC, and choose my compute instance, and I'll choose Web1. And the final step, we need to drop in the public key that will be used to validate the private key that we'll use when we create the session. So I'll drop in the public key I have there and create session. Again, that should just take a few seconds to do. And there it's done. Now, in the menu we see here, we have the SSH command that we'll use on your client PC or your client Mac to get through. So the SSH command is pretty horrific, not a problem. We can copy it by clicking there. Then go to my command prompt, paste in the command. I have to substitute where it says -I private key, I have to substitute the name of the private key I intend to present. We have to do it twice because we are going to be authenticating to the Bastion service itself, and then we will be doing the onward authentication to the Linux machine. And I'm using the same key for both of them, which would not be what you would do in a production environment. Your users would each have their own personal private keys. But that should work now. And there I am, logged on to my Linux machine from my PC as user OPC. To conclude, the Bastion service doesn't really offer anything that you can't do already with VPN servers and jump servers. However, it's a lot easier to configure, and you don't have to pay for extra compute instances or VPN licenses, and there's no maintenance needed. But best of all, it really is secure. Your jump servers and your VPN servers are only as secure as you can make them, whereas the Bastion is managed by OCI, and you can't get more secure than that. It's a good facility. Give it a try.
If you liked this video, please like it and subscribe to our channel.